How does a simple click on a website in New York result in a web page loading from a server in guided by a crucial protocol? Meet Border Gateway Protocol, the unsung hero behind the internet's highways. This protocol is the backbone of the internet, ensuring that data travels efficiently and reliably from one corner of the world to another. Alright, let's dive into it. Understanding BGP is like understanding the traffic system of a bustling metropolis, but on a global scale. Border Gateway Protocol, or BGP as it's commonly known, is the protocol responsible for exchanging routing information between autonomous systems, or ACE for short. These autonomous systems are essentially large networks that operate under a single administrative domain. Think of an autonomous system as a massive network, like your internet service provider or a big tech company. Each of these systems needs to communicate with others to ensure data can travel across the globe. BGP is vital for global connectivity. It's the protocol that makes sure your emails, videos, without it, the internet wouldn't know the best path to send your data. It would be like trying to navigate a net wouldn't know the best path to send your data. It would be like trying to navigate a city without a map or GPS. Imagine your data as a letter. Without BGP, it'd be like posting it without an address. The letter would wander aimlessly, never reaching its intended recipient. Now, how does BGP actually work? It's a bit like a sophisticated postal system, but instead of letters, it deals with data packets. Picture a network of highways. Each autonomous system is like a city, and BGP routers are the traffic directors. These routers are responsible for directing data packets along the best possible routes. These routers share information about available paths and determine the best routes based on policies and network attributes. They constantly evaluate and re-evaluate the paths to ensure optimal data flow. They use something called a path vector protocol and make routing decisions based on the AS path. This means they consider the sequence of autonomous systems a data packet must traverse to reach its destination. It's like choosing the fastest, safest route for vehicles, which in this case are data packets. The goal is to ensure data travels quickly and securely. BGP routers constantly communicate and update each other about the best paths. This dynamic exchange of information keeps the internet running smoothly. Now, imagine one of these highways suddenly gets blocked, perhaps due to a technical issue or a cyber attack. BGP adapts by finding the next best route, ensuring your data still gets to its destination. This adaptability is crucial for maintaining the reliability of internet services. This flexibility is why the internet remains scalable and resilient. It can handle growth and changes without significant disruptions. But it's not all smooth sailing. BGP has its challenges and vulnerabilities. Route traffic for nefarious purposes. This can lead to data breaches and other security issues. While we won't dive deep into those issues today, it's essential to know that BGP's robustness is both a strength and a vulnerability. The very features that make it powerful also make it a target for attacks. To recap, BGP is the protocol that keeps our internet traffic flowing smoothly across countless networks worldwide. It's the unsung hero that ensures our digital world remains connected. It's like the internet's traffic director, ensuring your data takes the best route every time. Without BGP, the internet as we know it would be chaotic and unreliable. If you found this explanation helpful, hit that like button, subscribe for more tech deep dives, and comment below with any questions or topics you'd like to explore next. Your engagement helps us bring more insightful content to you. Thanks for tuning in, and see you in the next video. Stay curious and keep exploring the fascinating world of technology.